Good morning, students. This is Ankit Joshi. I welcome you all to India's largest live learning platform, GradeUp. And today we are going to discuss complex variables in the upcoming 2 hours. Good morning, Sushant. How are you? So, this is about me. I have been teaching in this domain for more than 15 years. My subjects of interest are engineering, mathematics, analog circuits, and signals and systems. So, these are the batches currently going on our platform, GradeUp platform, that is Vision batch, Rank Up batch, and Gear Up batches. And please take the screenshot to know all the aspects of these batches. And if at all you wish to join any of these batches or one or more batches, then you can contact at the number given below 96500 And of course, these are our faculties who will be dealing with the batches associated with the ECE branch. Along with me, we have Rakesh Talreja sir, Sanjay Rathi sir, M.N. Ramesh sir, Chandan Jha sir, and Chaitanya Reddy sir. So you may be knowing that these are all prominent faculties and experts in their domain. These students, these images are of our previous year achievers. If you want to one among them, definitely you have to do or start serious preparation, and you need to join any of our platforms. So we'll start the session now. I can see Tilak. How are you, Tilak? Chale. So, which all topics we should consider in complex variables? Whenever you prepare for GATE examination, you have to consider some basics of complex algebra. Yes, Tilak. Then we have to go and consider analytic functions, complex integration, and number 4, we have to consider the Lorentz series part. Now, I want to tell you that when you, yes, meanwhile, I can see Ravi's, Jay Kumar. Good morning, beta. How are you? See, when we talk about basics of complex algebra, whatever you have studied, whatever you have learned in your 11th and 12th standard preparation for JEE, all those aspects you should consider. Moreover, you should know the concept of Euler's theorem for complex number, De Moivre's theorem, and related concepts. You must know the concept of complex variables, complex functions, their limits, continuity, and differentiability. So then we move towards analytic function. While we talk about analytic function, we basically focus on analytic functions, Cauchy's Riemann equations, that is the necessary condition for a function to be complex. And then we also consider harmonic functions. Harmonic functions, these are important criteria, these are important headings in analytic functions. Then when we talk about complex integration, we have to talk about Cauchy's integral theorem, Cauchy's integral formula, Cauchy's integral formula for the repeated roots, and of course the problem associated. We also have to talk about Cauchy's residue calculations and Cauchy's residue theorem. And then we have to deal with Lorentz series. So let us see till which heading I should explore in today's class. Okay, so and it purely depends on the interest of the students and the strength of the student attending this session. Okay, and their responses during the class. So I'll just give a quick recap of analytic function and its condition. We have a function of complex variable denoted by w, which is f of z equal to u plus iv. Here u and v both are functions of x and y. U and v both are functions of x and y. So for this function to be analytic, for this function to be analytic, for this function to be analytic, Cauchy's Riemann equations has to be satisfied. Cauchy's Riemann equation has to be satisfied. Number one, del u by del x equal to del v by del y. And second equation is del u by del y equal to minus del v by del x. This is Cauchy's Riemann equation. If f of z satisfies Cauchy's Riemann equation, then we can say that f of z is analytic. So these are the analytic, these are the necessary conditions for a complex function to be analytic. Then harmonic function. A function which satisfies Laplace equation in two dimensions is said to be harmonic function. So what is Laplace equation in two dimension? Laplace equation in two dimension is del square upon del x square, some function phi, del square phi upon del y square. This should be 0. So here this is Laplace equation and function phi is satisfying Laplace equation. So phi is said to be harmonic. A function which satisfies Laplace equation in two dimension is said to be harmonic function. A function which satisfies Laplace equation in two dimension is said to be analytic function. So what is the relationship between analytic function and harmonic function? See here. If w equal to f of z, which is u plus iv, be an analytic function, then real part u and imaginary part v must be harmonic functions. Wow, great. And since u and v are harmonic functions, therefore they must satisfy Cauchy's Riemann equation in two dimension. Extremely sorry. They must satisfy Laplace equation in two dimension. That is del square u by del x square plus del square u by del y square must be 0. And similarly, v is also harmonic, so del square v upon del x square plus del square v by del y square must be 0. So this is an important frame which can directly give you marks in GATE exam. Okay, so we have some questions here related with this basics and analytic function. The value of m for which this function is harmonic. So let us say this function is phi. 2x minus x square plus my square. If this function is harmonic, since phi is harmonic function, therefore phi must satisfy Laplace equation in two dimensions. So del square phi upon del x square, del square phi upon del y square must be 0. So partial derivative of, okay, first we will find del phi by del x. So del phi by del x will be 2 minus 2x and del square phi by del x square will be minus 2. Similarly, del phi by del y, partial derivative with respect to y, x will be constant, its derivative will be twice my, and double derivative will be twice m. So addition of these two will be 0. So minus 2 plus twice m equal to 0. So m will be equal to 1. Can I have your response? So m equal to 1 should be your answer. Can I have your response? Can I have your response? I request all of you to give responses. Jay Kumar. Chali. Requesting all of you to hit the like button. Requesting all of you to hit the like button. We'll move to the next. Take the screenshot, please. Understood? Now see here. If f of z equal to u plus iv is a complex analytic function where I equal to root of minus 1, then find the values of a and b. Okay. So f of z equal to u plus iv. What is u? Sir, u is real part, x square plus ay square. What is v? bxy. Del u by del x. Thanks for your responses. Yashashri, Jay, Ravi, Pankaj Kumar, Tilak. Thanks everybody. Aman Ravikar, Megha. Good morning, beta. So del u by del x. Twice x. Del u by del y. Twice ay. Then del v by del x. And del v by del y. Del v by del y will be bx. Now what is the Cauchy's Riemann equation? First equation. Del u by del x equal to del v by del y. So both of these are equal, these values. Twice x equal to bx. So b will be equal to 2. Another equation is, अरे भाई दूसरा Cauchy's equation कौन सा है? Second Cauchy's equation. Thanks a lot for your responses. Del u by del y will be minus del v by del x. Del u by del y equal to minus del v by del x. So twice ay minus by. You can just neglect this y. Twice a equal to minus b. A will be minus 1. So a equal to minus 1, b equal to 2. A equal to minus 1, b equal to 2. A equal to minus 1, b equal to 2. Option B is the correct answer. How is your preparation going on? Are you targeting for GATE 2021? Preparation कैसा चल रहा है? Pankaj, it's simple. The equations are simple, but still, if you are not able to relate, then you can see here. See del u by, suppose these are the four elements of the determinant. A11, A12, A21 and A22. Okay, then you can multiply these two. These are the first terms, so both are positive. And when you minus second term, multiplication of these two terms minus these two terms, it means these two terms are related with a minus sign and these two terms are positive. How to calculate the determinant, remember in your mind. Good. So now the real part of an analytic function f of z is given by e raised to minus y cos x. The imaginary part of f of z is, okay, so real part is given. Abhishek, I can take some sessions, that is the only thing what I can do. E raised to minus y cos x. Now del u by del x. E raised to minus y, derivative of cos x is minus sin x. Del u by del y. Okay, sir. So f of z is u plus iv. Tilak, you have to open your 11th and 12th standard book for that. On this platform, it is difficult to move away from these complex variables. So f dash z will be del u by del x plus I del v by del x. So f dash z del u by del x. What is del u by del x? Minus e raised to minus y sin x plus I sorry, by CR equation, this del v by del x equal to minus del u by del y. So this minus minus plus e raised to minus y into cos x. So we have got the expression for f dash z. So working rule is Milne-Thomson method. Which method we are using? Milne-Thomson method. So according to Milne-Thomson method, working rule is put x equal to z and y equal to 0. So e to the power 0, that will be 1 in sin z plus I e raised to 0 1 and cos z. So f dash z will be minus sin z plus I cos z. Integrate both sides. Integration of minus sin z will be, sin z integration is minus cos minus minus plus minus I sin z plus I sin z. So it will be e raised to I z. Something wrong. U is e raised to minus y cos x, del u by del x minus e raised to minus y sin x, del u by del y, yes correct, minus e raised to minus y cos x. So f of z is u plus iv, f dash z will be del u by del x plus I del v by del x. Del u by del x is minus e raised to minus y sin x plus I del v by del x is replaced by minus del u by del y, so e raised to minus y cos x. Working rule is x equal to z, y equal to 0. So sin z minus sin z, okay. Then cos z e raised to 0 is 1. Is that all fine? Integrating both sides, so you will be getting integration of sin z is minus cos z plus cos z will be the answer. Integration of cos z will be I sin z. Plus c. Is that all fine? So cos z plus I sin z. Is there some sign mistake? Okay, we'll revisit once. We'll revisit that question once. For an analytic function f of z equal to u plus iv, u equal to 3x square minus 3y square. So del u by del x will be 6x and del u by del y will be how much? Minus 6y. F of z is u plus iv. This is our analytic function. We will differentiate with respect to z. So we will be getting del u by del x plus I del v by del x. F dash z del u by del x, del u by del x, del u by del x. हाँ जी 6x. Del v by del x is minus del u by del y. So this will be plus 6y. Working rule, put x equal to z and y equal to 0. So only z. Integrating both sides, you will be getting f of z equal to 6z square by 2, that is 3z square plus some constant c. Now remember that if your imaginary part is absent, in that case this constant will be having imaginary part only. If your real part is absent, then this constant will be having only real part. If real and imaginary parts both are absent, then this constant will be c1 plus ic2, that is real and combination of real and imaginary. Now you can separate. Z means x plus iy. X square minus y square plus I 2xy plus c. So 3 times x square minus y square, this is your u, and I 6xy plus c, this will be the imaginary part. So instead of c they have used the constant k. Please take the screenshot. This is u, this is v. So v is 6xy plus c. Next. Now here f of z equal to x cube minus 3xy square plus I 5xy. Okay. F of z is an analytic function. You have to find out 5xy. Similar to the previous question. Take the screenshot, we'll move to the next. You can try it. Just v is replaced by the notation 5. Otherwise process will remain same. Now for this function to be analytic, what is the obstacle? रुकावट क्या है इसमें? The obstacle is this modulus function, because modulus function is not differentiable. Okay, so what you can do, you can remove this modulus part. So this modulus part will be removed, will be eliminated only when this second term is removed. So to make this second term, to eliminate this second term, what should be the value of b? B should be 0. If b is 0, in that case you will be getting twice z cube. So b equal to 0 is the answer, which will make this f of z to be analytic. This you can do. Please take the screenshot. Now see here. For an analytic function u plus iv, u plus v is given as 2x 1 minus y. Find out partial derivative of u with respect to x. Partial derivative of u with respect to y. Now find out partial derivative of just a moment. In that Vignesh, in that sense, that question cannot be framed now. Questions can be framed in which there will be some valid answer. You're getting my point? Whichever can be solved, that can be framed as a question. Correct? So suppose you have given 3 equations and they're asking for these 3 equations are involving 3 unknowns and they're asking for the values of 3 unknowns. It's not possible. So 3 equations, 3 unknowns. So proper data should be given. So if they are giving some interval 1 to 8, then they have to provide some more conditions. Okay. So whatever will be in your scope, whatever can be asked, whichever can be solved, they will give you proper data according to this, according to the requirement. So you have got the value of del u by del x and del u by del y. Okay. So u plus v is given, del u by del x is obtained, del u by del y is also obtained. Now find out del v by del x. So del v by del x, just a moment, I have done a mistake here. Del u by del x plus del v by del x will be 2 times 1 minus y. Del u by del y plus del v by del y will be minus 2 times x. Now this del u by del x as it is, this del v by del x is replaced by Cauchy's equation, del v by del x, del u by del y equal to minus del v by del x. What is CR equation? Del u by del y equal to minus del v by del x. This is second equation. What is the first equation? Del u by del x equal to minus del v by del y. So you can eliminate this del v by del x and del v by del y from both of these equations. So del u by del x as it is and del v by del x can be replaced by minus del u by del y. So this is 2x 1 minus, okay, 2 times 1 minus y. This is equation 1. And this del u by del y as it is, I am writing second. And del v by del y, see this del v by del y. Del v by del y is del v by del y is del u by del x. So this is minus 2x. You can add these two equations and find out the value of del u by del x. So when you add equation 1 and 2, 1 plus 2, 2 times del u by del x. This will be giving you, these two terms will be cancelled. 2 is taken common, minus x minus y plus 1. So 2 gets cancelled. You are getting the value of del u by del x. Minus x minus y plus 1. And similarly, if you do the subtraction, equation 2 minus equation 1, then del u by del x minus del u by del x strike out. Del u by del y plus del u by del y will be 2 times del u by del y, and subtraction is needed. So minus 2x minus 2 1 minus y. So what you can do now, del u by del y, 2 is taken common and cancelled, minus x plus y minus 1. So we have got the value of del u by del x and del u by del y. So these are the additional steps that you have to perform to get the value of del u by del x and del u by del y. Whereas in the previous question, in this question, they have given u, उन्होंने u दिया था, they have given u in the problem, so directly you got del u by del x and del u by del y. But in the current question, they have given you a linear expression in terms of u and v. So solving it simultaneously in this frame, we got the value of del u by del x and del u by del y. After getting the values of del u by del x and del u by del y, now you can frame f of z. What is f of z, beta? F of z is u plus iv. So f dash z will be del u by del x plus I del v by del x. So f dash z will be del u by del x plus I del v by del x by Cauchy's Riemann equation is minus del u by del y. So f dash z will be del u by del x is minus x minus y plus 1 plus minus times del u by del y, minus times del u by del y, minus times del u by del y. So x minus y plus 1. And now you can put the Milne-Thomson substitution, put x equal to z and y equal to 0. So you have got f dash z equal to minus z plus 1 and z plus 1. So in order to find f of z, you have to integrate. So 1 integration of 1 will be z minus z square by 2, and here z plus z square by 2 plus some constant c. So they have asked the value of f of z in terms of z. Okay, now in this question, if they would have asked for u and v, in that case you have to put z equal to x plus iy and separate the real and imaginary part. So this problem is little bit lengthy because initially you have to work out del u by del x and del u by del y. Otherwise, yes, Megha, take the slide, take the screenshot. Done. Now similar is this question. They have given you the value of u minus v. U minus v is e raised to x cos y minus sin y. So del u by del x minus del v by del x. Derivative of e raised to x as it is, cos y minus sin y as it is, equation number 1. Del u by del y minus del v by del y. E raised to x constant, derivative of cos y is minus sin y, derivative of sin y is cos y. So now if you add these two equations 1 and 2, you will be getting some expressions. See here, del u by del x plus del u by del y. Just a moment, I have to do some manipulation now. Equation 1, we will apply Cauchy's Riemann equation in this. So del v by del x is minus del u by del y, correct? So minus minus plus del u by del y. So right hand side remains same, no response. Now equation 2 will become del u by del y is our second term, and this del v by del y is del u by del x. So minus as it is del u by del x. Equation 4. What you can do now, you can add these two equations together. इन दोनों equations को add करना है भैया. So del u by del, okay, if I add these two equations, then del u by del x and del u by del x cancelled, 2 del u by del y will be obtained. Okay, so if you add then cos y cancelled, minus sin y, so minus 2 sin y e raised to x. So del u by del y is minus e raised to x sin y. And if you subtract, equation 3 from equation 3 minus 4, then 2 times del u by del x, e raised to x common, subtraction, so cos y 2 cos y, minus sin y plus sin y cancelled. So this is the value of del u by del x, and this is the value of del u by del y. So now you can proceed further. What is f of z? F of z is u plus iv. F dash z is del u by del x plus I del v by del x. Del u by del x minus del u by del y by CR equation, and now I need the substitution. So del u by del x is e raised to x cos y, and I need minus del u by del y, minus minus plus e raised to x sin y. Now what is the working rule? By Milne-Thomson method, x will be replaced by z and y by 0. So I have got e raised to z cos 0, and then I have got I e raised to x sin y. So if I integrate this e raised to z, I will get e raised to z plus c. Now I can separate the real and imaginary parts. F of z is e raised to z. Z is x plus iy. So this is e raised to x, e raised to iy plus c. So e raised to x as it is, by Euler's theorem, this will be cos y plus I sin y. So e raised to x cos y plus some constant c1, e raised to x sin y plus some constant c2, and here you have I. So this is your u, this is your v. Mega, what you want? No. Cauchy's integral theorem. Suppose we have a, I'll just explain this here. We have a closed curve C. This closed curve C encloses a region R, and we have a function f of z which is analytic inside the region and on the boundary of this region. Then closed loop integral of f of z over this curve C will be 0 according to Cauchy's integral theorem. Cauchy's integral theorem. Consider a closed curve C which encloses region R inside it. Let f of z be complex function which is completely analytic in the region R. Completely analytic means not having any singular points. Completely analytic in the region R and on the boundary. Then by Cauchy's integral theorem, integration of closed loop integral of f of z will be 0. Now see, evaluate this closed loop integral. A function of z is given. येलो वाला कैसे हुआ? हमको तो नहीं दिख रहा कोई जे यहाँ पर. J or I is not mentioned anywhere in this screen. कहाँ पर है? When you combine U and V, then I or J will appear. In this frame, simply you have added and subtracted these derivatives. Mega. So this is a circle whose center is at origin and radius equal to 2. This is your mod z. Now see, this you have to integrate this function. Let us say that this is g of z. 4z minus 3 upon z minus 4, z minus 5. Whenever you equate this g of z to 0, you will be getting the poles. Z equal to 4 and z equal to 5, these are the points on real axis outside the circle. Since both of the poles are lying outside the circle, since both lies outside the circle, mod z equal to 2, none of them is singularity. None of them is singular point. None of them is singular point. It means g of z is completely analytic. G of z is completely analytic function in the region mod z equal to 2. So when the given function is completely analytic in the given region, then its result will be 0. Now see here. If you have a closed curve C, in this closed curve C, there is a region R. This region is region R. This closed curve C is having a function g of z, and this g of z is having singularity at z equal to a. Then integration of this g of z will be 2 pi I f of a. See here. If we have a closed curve C, this closed curve C encloses a region R inside it. So this region is region R. Whenever there is a closed curve, it encloses some region inside it. Now in this region, a function is defined. Let us say that function is g of z. G of z is having a singular point at z equal to a. Okay, so g of z is having a singular point at z equal to a. So I want to separate this singular point from g of z. So g of z is having singular point at z equal to a. It means z minus a will be a factor in the denominator. That it means. And the remaining function will be f of z. In that case, if you integrate g of z over this closed curve C, it means you are integrating f of z upon z minus a. So this integration will be 2 pi I times this numerator f of z evaluated for z equal to a. This is Cauchy's integral formula. That's what is being discussed here. Consider a closed curve C which encloses a region R. Let g of z be a function defined in the region R which is having a singular point at z equal to a. So in this case, g of z equal to f of z upon z minus a, where f of z is completely analytic function in the region R. See, g of z is having singularity at z equal to a. So if you remove this singularity from g of z, what is remaining? Remaining will be f of z. Arey bhai, if there is some singularity in a function, if you separate that singularity, the remaining will be smooth function, analytic function. So f of z upon z minus a dz will be 2 pi I times f of a. This is Cauchy's integral formula. Now please see here. See, I can solve these questions in 30 seconds also, 1 minute also, less than that also. But in order to explain everything, I am just drawing and writing all these steps so that you can refer it for your future reference. So mod z equal to 4, this is the boundary of the region. So this is a circle with center, this is a circle, center at origin radius equal to 4. Now this is your function. 2 and 5 are the poles. So 2 is inside and 5 is outside. So g of z is 4z minus 3 upon z minus 2, z minus 5. So z minus 5 is outside. It is not a singular point, but this is a singular point. So singular point term should remain in denominator. So 4z minus 3, z minus 5 is clubbed with numerator and z minus 2 remains in denominator. Hello, out of these two factors, 2 is the singular point, 5 is not the singular point because 5 is lying outside the region. If some tree, some obstacle is there outside your plot, it's not an obstacle for you. So 5 is not obstacle for us because our region is this one. This circle is our region, understood? So this 5 is not the obstacle for us. So this 5 should be clubbed with the numerator. So 4z minus 3 upon z minus 5 and z minus 2, this is the singular point. This is the factor corresponding to the singular point, that this should remain in denominator. Okay. So we can write this as numerator as f of z and denominator as z minus 2. So integration of g of z over the curve C, this will be 2 pi I f of z evaluated at 2. This is Cauchy's integral formula. And this numerator is f of z. So in this f of z, this is your f of z. You have to put z equal to 2. So 4 2s are 8, 8 minus 3 is 5. 2 minus 5 is minus 3. What is this? 4 2s are 8, 8 minus 3 is 5. Then 2 minus 5 is minus 3. So our answer should be minus 10 pi I by 3. No responses? Students, I need your response. If you have any doubts, please let me know. Please let me know if you have any doubts regarding this integration. Yes, Megha. Very good, beta. Now see here. See here. Closed curve C enclosing the region R. a function g of z is defined. In this g of z, in z equal to a, this singular point is repeated n plus 1 times. See, this crosses represents the repetition of the singular point. This is the repetition of the singular point. Okay. Pranay Deep, Aman, Megha, thank you beta. So integration of g of z dz, what you have to do, you have to separate the singularity from this g of z. So f of z is the remaining part which is completely analytic, and we separated this n plus 1 times repetition of singular point, that is z minus a is repeated n plus 1 times in the denominator, z minus a to the power n plus 1. So answer for this integration will be 2 pi I upon factorial n. If it is repeated n plus 1 times, you have to consider factorial n in the denominator, and nth derivative with respect to z for f of z, evaluated for z equal to a. Now see here. Circle is mod z equal to 3. So this point is 3, this point is minus 3. And poles, okay, this is g of z. Equating the denominator to 0, z equal to minus 1 is the pole. So that this pole will be lying inside the circle. Once it is lying inside the circle, it is a singular point. Okay, sir. So e raised to 2z बहुत सारा पोर्शन रिमेनिंग है, टाइम कंस्ट्रेंट है ना बेटा, क्या करें. z minus of minus 1, power 4 can be written as 3 plus 1. So here n is 3, a is minus 1. Yudhishthir, I equated this denominator to 0. I got the value of z equal to minus 1. So z equal to minus 1 is lying inside the circle. Therefore, this is a singular point. If this would be lying outside the circle, then it will not be an obstacle. It will not be a singular point. So, answer for this will be 2 pi I upon factorial n, nth derivative of numerator evaluated for z equal to a. A is minus 1. So 2 pi I factorial n is 3, factorial 3, third derivative of this f of z, e raised to 2z, evaluated for z equal to minus 1. So 8 e raised to 2z, evaluated for z equal to minus 1. 16 by 6, that is 8 by 3 pi I e to the power minus 2. This will be the answer. Now see here, mod of z equal to 5. Yudhishthir, Bahela, mod z equal to 5. This is a circle of radius 5. This is a circle of radius 5. Okay, sir. So this point is 5. This is your function g of z. When you equate the denominator to 0, you will get the poles. So poles are 2 and 3. So 2 and 3 both lies inside the circle of radius 5. Correct? Both lies inside the circle of radius 5. Okay, sir. So both are singular points. Both are singular points. So 4z minus 3, this is your numerator, and 1 upon z minus 3 minus 1 upon, okay, what we can do? So z minus z cancel, minus 2 minus minus plus 3 will be 1. Okay, so we have done the partial fractions for this denominator. 4z minus 3 is out. 1 upon z minus 3 minus 1 upon z minus 2. Solve this, solve this. So denominator will be the product of these two. We obtained the product. Z and minus z will be cancelled. Minus 2 and plus 3 will be 1. Okay, so both of these are exactly equal. Now this g of z can be splitted into two parts. 4z minus 3 upon z minus 3 minus 4z minus 3 upon z minus 2. Can I have your response? Let us say this numerator 4z minus 3 is f of z. So now if you integrate both sides, what will you get? Integration of g of z dz, integration of f of z upon z minus 3 dz minus integration of f of z upon z minus 2. By Cauchy's integral formula, this will be 2 pi I f of 3 and this is 2 pi I f of 2. And remember, f of z is 4z minus 3. F of z is 4z minus 3. This numerator is f of z. So f of 3, 4 3s are 12, 12 minus 3 is 9. F of 2, 4 2s are 8, 8 minus 3 is 5. So 18 pi I minus 10 pi I will be 8 pi I will be your answer. So what you have to do here? I have dealt with 4 varieties of questions here. In the previous four questions includes 4 varieties. So in this particular question, you have to do the partial fractions because more than one singularity is lying in the circle. Okay, यशश्री क्या कर रहे हो बेटा? In this question, singularities are repeated. In this particular question, there is only one singularity, and in this particular question, there is no singularity. So when there is no singularity in the region R, answer will be 0. Cauchy's integral theorem. When there is no singularity in the given region, then there will be Cauchy's integral theorem. Answer will be 0. When there is only one singularity, you have to apply Cauchy's integral formula directly. When there are repeated similarities, you have to apply this formula, three formulae. And when there are more than one similarity in the circle, in that case you have to do the partial fractions. So four varieties of questions are dealt with. So if you clearly understood this, then definitely you can score marks. मेघा partial fraction किया ना बेटा, you have done partial fractions. After doing the partial fractions, we are getting a minus sign here, so that minus sign will be available between. How can you distribute it into two parts? You have done the partial fractions. These are the partial fractions. Solve this. Solve this question and give me 1 minute. No, answer is not zero बेटा, थोड़ा सा एफर्ट लगाइए, apply some efforts. हमको जिस दिन वो मिल जाएगी ना, लेकिन ब्रश मिल जाएगा फिर प्लेट नहीं मिलेगी। हाँ बोल। हाँ देना मुख का बोले। हाँ जा अंदर जाए। क्लास कब तक होगा? मेघा जीरो आंसर नहीं आता बेटा, जीरो आंसर नहीं आता। Why you are getting zero answer? Because you are equating the denominator and you are getting value mod z equal to 3. But this is mod z and this is z bar and this is mod z. Both are different beta, both are different. We need poles in terms of z, not in terms of z bar. All my dear students, प्यारे प्यारे बच्चों, see circle of radius 1 और हम यहाँ क्या करेंगे? What we will do here? Mod z will be dz upon 3 minus this z bar as it is, multiply and divide by z. For your information, z into z bar is mod z square upon z as it is. So this will be 3z minus mod z is 1. Arey bhai, mod z is 1. And this z after taking LCM will appear in the numerator. Okay, sir. Taking 3 common from the denominator. So now the pole is 1 by 3. 1 by 3 is lying inside the circle. So answer will be 2 pi I, 2 pi I, 2 pi I. This numerator function evaluated at 1 by 3. So 2 pi I 1 by 9 will be the answer. Good question. Everybody followed the approach? I request all of you to hit the like button. Yes, moving to the next. अयान, सुशांत, अरे भाई क्या नाम है आपका? RM10 गेमिंग। Cos pi z square upon z minus 1 z minus 2 dz. C is a circle, mod of z plus I equal to 1.5. Yes, very good question it is. Now see, z plus I equal to 1.5. Interpret this circle. सबसे पहले इस सर्कल को इंटरप्रेट करेंगे. x plus iy plus I modulus equal to 1.5. So x square plus y plus 1 square 1.5 square. This is the circle. Circle center is at 0, minus 1. Radius equal to 1.5. Good one. Center at 0, minus 1. Radius is 1.5. This center is minus 1, magnitude part. Radius is 1.5, so this is 0.5. Radius is, let us find out this distance. So this distance is nothing but the radius. Okay. This distance is 1 unit. Can you calculate this distance? Let us say this distance is k. By Pythagoras theorem, k will be under root 1.5 square minus 1 square. So k will be under root 1.25. So k will be 1.1. So this point will be 1.1, near about 1.1. Now what are your poles? What are your poles? Poles are 1 and 2. By equating the denominator, poles are 1 and 2. So 1 will be lying inside and 2 will be lying outside. So applying Pythagoras theorem to get this value of this distance is important, because I was in a conflict that whether this point 1 is lying inside or outside the circle. I was in a conflict. So I just calculated k, this distance from origin to this point. Okay. So this is 1.1. It means 1 is lying inside and 2 is lying outside. So 1 is the singular point, 2 is not the singular point. So cos pi z square upon z minus 2. This will be our f of z upon z minus 1 dz. So 2 pi I, evaluated this numerator at 1. So cos pi minus 1 minus 1. Cos pi is -1, 1 minus 2 is -1. My answer will be 2 pi I. Okay, question is not difficult. With this question, I tried to convey this concept that whenever you are in a conflict in such type of questions, then you can apply Pythagoras theorem and check whether what is the distance from origin to that intersection point of circle and the x-axis or y-axis, x-axis particularly, so that you will be able to decide whether the point is lying inside or outside. Take the screenshot, please. All of you, please hit the like button if you have not done so. This is the only source of energy for me. Now, calculation of residues. Residue of simple pole. Simple pole means the pole which is not repeated. Simple pole z equal to a. This is limit z tending residue of f of z at simple pole z equal to a. Limit z tending to a, z minus a into f of z. This is the formula. If poles are repeated, you have to call them repeated poles. So residue of f of z at repeated pole. Whenever we say repeated pole, you have to mention the index, how many times it is repeated, of index n plus 1. So for this we have a small formula. Residue of f of z at repeated pole z equal to a of index n plus 1. So it should start with 1 upon factorial n limit z tending to a nth derivative with respect to z, z minus a to the power n plus 1 f of z. These are the formulae for the calculation of residue. Please take the screenshot. Same formula is being written here also. You can take the screenshot, please, if you have not done so. Now see here. How many poles you can see here? The residue of complex function x of z 1 minus 2z upon z into z minus 1 z minus 2 at its poles. So poles are z equal to 0, z equal to 1 and z equal to 2. So residue at z equal to 0. What do you have to do? Limit z tending to 0. One minus, okay, limit z tending to 0. So z minus 0 into the same function x of z. So z and this z gets cancelled. So 1 minus 2z upon the remaining. Zero. 1 minus 1 minus 2 is 2. 1 by 2 is the first residue. R2. Limit z tending to 1, z minus 1 into x of z. So this 1 is eliminated, z minus 1 is eliminated from the denominator, and in the remaining part you have to put 1. So 1 minus 2 is minus 1, 1 into 1 minus 2 is minus 1, so answer will be 1. So 1 by 2 and 1, these are the 2, 1 by 2 1, 1 by 2 1. Okay, so you have to find out one more. Z equal to 2. So this z minus 2 will be eliminated. 1 minus 4 is minus 3, and 1 into 2 minus 1, that is, so I guess minus 3 is the answer. Z is 2 na? 1 minus 4 is minus 3. Z minus 2 is eliminated. 2 into 2 minus 1, that will be 2, minus 3 by 2. So 1 by 2, 1 and minus 3 by 2. Haji. So we have got the poles z equal to 2 and z equal to minus 2. We want the residue at z equal to 2. Okay. So residue for z equal to 2. How many times it is repeated? 2 times. So 1 by factorial 2. Limit z tending to 2. Z minus 2 whole square into f of z. Just a moment. This is repeated pole. So nth derivative. Nth derivative. It is repeated 2 times. So nth derivative will be first derivative. And here z minus 2 square into f of z. 1 by factorial 1 is 1. Z tending to 2. Z minus 2 square gets cancelled. So 1 upon z plus 2 square. D by dz. So differentiation of this will be minus 2 upon z plus 2 cube. Put z equal to 2. We'll be getting minus 2 upon 2 plus 2 will be 4. 4 cube is 64. Minus 1 upon 32. Consider the following complex function f of z equal to 9 upon z minus 1 z plus 2 square. Which of the following is one of the residues of the function? Okay, it means you have to find both the residues. So first of all, we'll find residue at z equal to 1. So limit z tending to 1. So z minus 1 cancelled. in this remaining function you have to put z equal to 1. So 9 upon 9, that will be 1. R2, residue at z equal to minus 2, another pole. It is repeated 2 times. 1 by factorial 1, limit z tending to minus 2, z, okay, d by dz, first order derivative, and z plus 2 square into this function, that is 9 upon z minus 1. So it will be minus 9 upon z minus 1 whole square, and you have to put the limit z tending to minus 2. So minus 9 upon minus 3 square, that will be 9. Answer will be minus 1. Now Cauchy's residue theorem. Integration of f of z dz will be 2 pi I sum of all the residues. So you have to consider the residues of only those poles. You have to consider the residues of only those poles which are singular points here. Okay, so 2 pi I sum of the residues of all the singular points. So whatever will be the singular points, that will be it means the poles which are lying inside this region, they will contribute only to this integration. See here, this is your function f of z 3z plus 4 z into z minus 1. So R1, residue at z equal to 0. So z cancel, in the remaining you have to put z equal to 0. So 4 upon minus 1, that is minus 4. R2, residue at 1. Z minus 1 f of z. So in this function you have to put z equal to 1. So 3 plus 4 is 7, 7 by 1 is 7. So answer for this integration is 2 pi I sum of the residues of the singular points. Both are singular points because both are lying inside this circle. 0 and 1 both lies inside this circle. So both will contribute to this. एट आया क्या बेटा? तारिक भाई, गुड बेटा, शाबाश. Now see it. Mod of z minus 1 equal to 2. We will be solving this using Cauchy's residue theorem. Huh? So this mod of z minus 1 is can be written as x plus iy minus 1 equal to 2. So x minus 1 is square plus y square equal to 2 square. This is the circle, center at 1 comma 0 and radius equal to 2. Center at 1 comma 0 and radius equal to 2. Now, poles are -2 and +2. So -2 will be definitely lying outside and +2 is lying inside. So only this residue corresponding to z equal to 2 will contribute to the integration. So 2 pi I residue of f of z at z equal to 2. This z equal to -2 is lying outside, it will not contribute. So one upon factorial 1 limit z tending to 2 d by dz z minus 2 whole square into 1 upon z plus 2 whole square into z minus 2 whole square. Calculate the residue. 1 upon factorial 1 is 1. So z minus 2 whole square cancelled, minus 2 upon denominator's cube. Z minus 2 whole square cancelled, minus 2 upon z plus 2 whole cube, and you have to put z tending to 2. 2 plus 2 is 4. 4 cube is 64 minus 1 by 32. So answer will be 2 pi I 2 pi I. So this will be minus pi I by 16. An image gen. Yes. So we'll be winding up the session, and yeah, YouTube sessions cannot be longer than 90 minutes or 1 hour, but anyways I conducted it. So how was the session? You can just comment in the comment box. We will be coming up with some more sessions on the same topic, similar topics, complex variables and differential equations in near future. Thanks a lot, and we will be just continuing from the same point where we stopped. Thanks a lot. We'll meet in some more classes. We'll try to see, faculties are very much packed in their classes in the paid courses, but if we are finding some time to have the some sessions in YouTube and free app. So that's all. Thanks a lot. We'll arrange some more sessions. We'll try to arrange some more sessions. Do provide a productive feedback. Do like the session and share the link among your friends also. Thanks a lot. Bye bye. Take care. Best of luck here for exams. May God bless you all. Most probably next weekend. Rajshekhar, straight away it is not mentioned in the syllabus, but this will be always good on the being on the safer side to prepare, because this is not a topic to invest more than 3 to 4 hours. You can invest some 3 hours of time and learn some basics of the subject, because sometimes this can give you some marks in your subject, in your branch also. Straight away this is not given in the syllabus, but you can expect very rarely one question from it. Bye bye. Take care. Best of luck. We'll meet on the next weekend.